Alright, today we're going to talk about solving absolute value equations, both when they're equal to or if they're using an inequality. Our essential question is, how can you find the solution of an absolute value equation? And an example of or what you need to remember about absolute value is this. If we're looking at an equation like the absolute value of x is equal to 7, we know that's true when x is equal to 7 or x is equal to negative 7, because the absolute value of both of those is 7. So to solve an absolute value equation, we set it equal to the positive and the negative. Okay? So we end up solving two equations when we're doing this. The steps to solve it, we start out first by isolating the absolute value, and I'll show you that in an example. Just like when we're solving an equation and we want to get it x equal, or we want to isolate that variable, now we're going to isolate the absolute value part. Then two, we're going to set up what's inside the absolute value and set it equal to the positive and the negative of what it's equal to. And again, I'll show you that in the problem. And then we solve both problems for x. Okay? So it looks like this. We start off with a problem like this. The absolute value of 2x minus 1 equal to 5. It's already isolated. There's nothing being multiplied or added or subtracted outside the absolute value. So we're going to set what's inside equal to the positive 5, or what's inside is equal to the negative 5. Okay? And then we're going to solve for x for each of them. Add the 1, bring down the 2x, you get 6. Divide out the 2, x is 3. Over here, add the 1, negative 5 plus 1 is negative 4. Bring down your 2x, divide out the 2, x is equal to negative 2. So as long as x is 3 or negative 2, this is a true statement, and you can check it. 2 times 3 is 6, minus 1 is 5, the absolute value of 5 is 5. Plug in negative 2, 2 times negative 2 is negative 4, minus 1 is negative 5, the absolute value of negative 5 is 5. So it works for that. So let's take a look at another example. 3 times the absolute value of x plus 2 minus 1 equals 8. Isolate it first. Get rid of addition and subtraction first. Just like you solve your normal equations. Divide out the 3. Don't try to distribute it there. Those aren't parentheses. That's absolute value. So now we sit here with x plus 2 is equal to 3. Okay, so we've isolated it, just like we're to that point now. Now set the two problems up. X plus 2 could equal 3, or x plus 2 equals negative 3. And then solve them like you've been solving them. Subtract the 2. X is equal to 1. Subtract the 2. Negative 3 minus 2 is negative 5. So if you want to check them, plug in 1. 1 plus 2 is 3. The absolute value of that is 3. 3 times 3 is 9, minus 1 is 8. So that checks. Plug in negative 5. Negative 5 plus 2 is negative 3. The absolute value is positive 3. 3 times 3 is 9, minus 1 is 8. So it checks. Okay, so that works. So that's when it's equal to. Well, if it's an inequality, it's still the same type of thing. We're going to solve it the same way. We want to isolate. I want to subtract my 3. Less than 15. Okay. I didn't have to divide by a negative, so I don't flip my sign, just like what we were doing with regular inequalities. But now I've got it isolated. So 3x minus 6 is less than 15, or 3x minus 6 is... Now when I make this negative 15, remember what we talked about with inequalities? When you multiply by a negative, you've got to flip the sign. Well, that's kind of like what you're doing here. This is a less than, now it becomes a greater than. Okay, that's a key point right there. Make sure, switch your signs. Okay, when you change to the negative, switch your signs. Then solve them. Add the 6. 3x is less than 21. Divide out the 3. X is less than 7. Add the 6. 3x is greater than negative 9. divide out the 3, x is greater than negative 3. Okay? Don't try to flip the sign here because that's negative. You divide it by a positive, so it stays the same. If you want to look at this graphically, let's see, we got negative 3, put 0 here, 7 here. We're going to get a circle here and x is less than. We're going to put a circle here and x is greater than. So as long as x is between those two, this is true. Like if I put 0 in here, 0 would give me negative 6. The absolute value is positive 6. 6 plus 3 is 9. Is that less than 15? Yes. Okay. So any number between negative 3 and 7 is a solution for us. Now, just like we've been working other equations along the way, sometimes you get some of these equations here, and you can get infinite solutions or no solutions. Here, the absolute value of 2x plus 1 is greater than or equal to negative 9. The absolute value is always positive. So no matter what you put in for x there, when you figure this out and take the absolute value, it's always going to be positive. So it's always going to be bigger, in this case, negative 9. So what's our solution here? All real numbers. Okay? This is always true. The absolute value is always bigger than a negative. So your answer is all real numbers. Okay? So be aware of that as you work through some of the problems. Okay? So that's solving absolute value equations. You solve them by isolating that absolute value, then setting them equal to the positive and the negative answer that you happen to have there, and then solve them both for x. You can plug them both back in and check and see what works. When you get an inequality, graph it so you can find the area or the range of your solutions. Okay, hopefully that's been helpful. When you get into class tomorrow, we'll go over some sample problems. All right, hope that helps. Have a good one. Bye.